and getting that in place as well. So we've got our powers of I and our complex multiplying and dividing with complex numbers. So let's take a look at what happens when we multiply these things. So as we look at our multiplications, if we have a monomial times a binomial, all we need to do is distribute. And again, we've been distributing since way back in basic algebra. So 3i times 2, what's that going to give you? Big old fat 6i. 3i times a negative 7i. So 7 times 3 is a negative 21i squared. But we found out the other day that anytime I ended up with a I squared, all I squareds are equivalent to a negative 1. So here, put that up the top here. I squared equals a negative 1. So what I really have here is 6i minus 21 times a negative 1, or my final answer is 6i plus 21, because it's going to change the sign of that number at the tail end. So always if we get I squareds, we need to take care of that so that we get that into the value of a negative 1 and work through it in that manner. Okay, so what happens with the next one? Well, this one we need to FOIL. And we've been using FOIL through a lot of different things. So 5 times 2 is 10. 5 times 6i is a positive 30i. I times 2 is 2i. And I times 6 is a plus 6i squared. But the 6i squared needs to be fixed. So it is really going to become a positive 6 times a negative 1, or a negative 6. So now I have 10 plus 30i plus 2i minus 6. Last off, combine like terms. 10 and a negative 6 gives me 4. 30i and 2i gives me 32i. So I need to go back and combine like terms and like variables within that. So you want to go through and make sure that you get your pieces put back together and get it so it's worked out to be one set thing, as opposed to having different pieces in there. So multiplying again, just FOIL and make sure you get what you should have with those. This next one in C puts radicals in here as well, and it puts i's in there. So we have both combinations. So we've got the radical pieces that again is a straight multiplications we've done before. Square root of 2 times the square root of 2 is 2. Square root of 2 times a negative I is a negative I, the square root of 2, since I can't put those together. Negative I times the square root of 2 is again a negative I, square root of 2. And finally, a negative I times a negative I is a plus I squared. But because it's an I squared, it's really a negative 1. So I have 2 minus I to the square root of 2 minus I to the square root of 2 minus 1. Putting stuff together, 2 and a negative 1 is 1. A negative 1i and a negative 1i with the square root of 2 with both of those is a negative 2i, the square root of 2. So it's not hard, it's just that you got a couple new little twists to it where you got to keep track of that I squared that you happen to have. So what do we get on this one? So if we work that one out, what happens to it? So see what you get for your final answer. Anybody have an answer we should have for it? -1 plus 3i. Okay. Do I need to go through it, you think? Or are we good? I better go through it just so that what's up here. -1 times 2 is a -2. -1 times a negative I is a plus I. Plus I times 2 is a plus 2i. And finally, a positive I times a negative I is a negative I squared. So this piece is going to actually become a plus 1. So I have -2 plus I plus 2i plus 1. -2 and a plus 1 is a -1. And my i's give me 3i. So we do have it worked out in there. So these aren't too bad. They just involve making sure that you take some time to use your foiling and make sure you go through and do those. Let's take a look at a couple more here and see what we can come up with for answers for these. Because not always do they all combine together. So -2 times a -8 is 16. -2 times a -9 is a plus 18i. Positive 2i and a -8 is a -16i. And last of all, a -2 times or positive 2 times a -9 is a -18. I times I is I squared. So this changes. Be real careful in those ends. So it's going to become a positive 18. So now I have 16 plus 18i minus 16i plus 18. 16 plus 18 is 34. Positive 18 and a negative 16 is a positive 2i. And that's my final answer. I can't do anything else with it. Okay. This other one has combinations in here. 9 times 2 square root of 2 is 18 square root of 2. 9 times 4i is plus 36i. 7i times 2 square root of 2 is 2 times a -7 is 14. But the I comes along and the square root of 2 also comes along. Then finally, -7 times a positive 4 is a -28. And I times I is I squared. But within this, there isn't anything else to combine. I can't put anything together in there. So I'm left with 18 the square root of 2 plus 36i minus 14i the square root of 2. This is the only piece that changes. I squared is going to make it positive because a -1 times a -28 is a plus 28. And that's all you can do with it. I cannot put 18 and 14 together in here because this does not have an I and that does. So you got to look at every little piece as you go through so that you get your pieces in there for what's happening with those. Multiplication of complex numbers. You cannot ever multiply a -6 and a -2 to get a positive 12. It doesn't work that way because these are imaginary. So the only way I can work with this is to make sure that I pull out an I before I work with it. So be real careful that if you got a negative underneath your radical, that you do end up pulling that out of there so that you end up getting your I values in here. Then once you get this, then you can multiply your values together and come up with what it would end up being. So be real careful in making sure you watch out for those type of things. So remember that A times B is the square root of AB only if A and B are non-negative real numbers. So if there's any negatives under there, you're going to need to make sure you remove those first. So if I had the square root of a -5 and the square root of a -6, to do this one, and I'm multiplying those, I need to have I the square root of 5 times I the square root of 6. Then I can multiply my stuff underneath and get I squared the square root of 30, and then end up with a negative square root of 30. So be real careful when you work with those, that if you've got an I or a square root of something in there, that you come up with that. If only one needs to be done that way, You only do the first one. So if I work with this piece, I'm going to pull out an I, and that's square root of 7 times the square root of 9. Now I can end up multiplying these. That I still needs to be part of my answer, and I get the square root of 63. But 9 can be removed, so really I end up with 3I, the square root of 7, because I happen to be a perfect square root within that one. This is 9.2. I think 9, you feel like it goes on forever, and it's got a lot of sections and a lot of pieces to it, so be careful with those things and what you get going there. So just be careful with those negative stuff in there. So then division is not any different than what we did before. It's just that now we have an imaginary number. So we're going to multiply both sides, the numerator and denominator, by the complex conjugate of the denominator. That was when we had something like the square root of 4, or square root of 2 minus 7, and its conjugate was the square root of 2 plus 7. And we did that in 9.4c was where we did it at. So we've got to get conjugates in there. Simplify the resulting products by multiplying both by the numerators and denominators, and then write the simplifying result in standard form. So we have to go make sure we simplify stuff. So if we take a look at these guys and work them out, what do we end up having to do? Well, with this one, my conjugate, what's it going to be? I got a conjugate there. What will it end up being? Elizabeth, what do you think? What would my conjugate be? Okay. A negative, yep, a negative 1 plus 5i. Because if you remember, it's going to be the same two numbers out in front, but the sign is going to change. And when I do that, what it's going to do for me in this case is going to get rid of my i's. Because in 9.4 or C, we were getting rid of radicals. But now we got to remove the i's out of the denominator, and so we want to make sure you get that conjugate out of there. So 4 times a negative 1 ends up being a negative 4. 4 times 5i is a plus 20i. In the bottom, because it's a conjugate, I don't need to FOIL the whole thing. I only need to use F and L, so I need to do the first terms. It's going to give me 1. Do the last terms, it's going to give me a minus 25, and I'm going to end up with an I squared. So this is going to still be a negative 4 plus 20i. In the bottom, that I squared makes it a negative 1 times a negative 25 makes it a plus 25. So I have a negative 4 plus 20i over 26. But I need to simplify it. So what happens to simplify it? What would I have to do if I'm going to simplify it? Well, in this case, what can I pull out of the top that's common to the bottom? So I'm kind of looking for a common factor. So I could pull out a 4 out of the top. And in the bottom, what can I pull? I can't pull a 4 out of 26, but I can pull a 2 out of 26, because then the 2 and the 4 will cancel, and I'm left with 2 times a negative 1 plus 5i all over 13. And then that is considered simplified. So if you get an answer, Hawks, and you put this in, let's say you go in Hawks and you type this in as your answer, it's going to say, but come back and say it's not simplified. So what that means is that they're just taking this thing and they're reducing it. So they're trying to get it to its lowest term. So it's a reducing that you're going to do. So you're going to look for some common stuff in there that we can take and reduce stuff with. Here's another one. So its conjugate, what do you think? What should its conjugate be? So square root of 3 and an I, because I need the matching stuff. but because it's subtraction in the middle, the conjugate is going to be the opposite sign of that. So then I have two problems in here that I'm going to multiply. So it's like having two of the first beginning problems that I had that I need to multiply out. So square root of 3 times square root of 3 is 3. Square root of 3 times I is a plus I, the square root of 3. I times the square root of 3 is a plus I, the square root of 3. And last, I times I is I squared. Then the bottom, because I forced it to have a conjugate, the only pieces I need to multiply, because my middle disappears, is the square root of 3 times the square root of 3 is 3. Negative I times a positive I is a negative I squared. And then I can go back through and simplify all of my pieces. 3 stays. I, the square root of 3, and I, the square root of 3 becomes plus 2. I, the square root of 3. And this I squared ends up becoming a negative 1. The bottom becomes 3. Square root of 2 is a negative 1 times a negative 1 is a plus 1. So I'm left with 3 minus 1 is 2, plus 2i, the square root of 3, all over 3 plus 1 is 4. But I can pull out a 2 and cancel out and reduce stuff. 2 is into 2 once, 2 goes into 4 twice. So my final answer is 1 plus I, the square root is 3, all over 2. And so that becomes my answer to this one. So when we're going through it, we've got some simplifications to do. Questions with this one? This one's kind of quite involved because it's got a lot of pieces to it. So again, we found the conjugate, foiled everything in both top and bottom, but on the bottom, I only needed to use the F and the L from FOIL, because I only have to do the first term and I only have to do the last term, because my middles, because of the conjugate, will disappear. So they're no longer there. And so that's not part of that answer. And then got over here, multiplied everything out, simplified, took care of my x squareds, combined stuff together, came up with what my answer would be in the very bottom. Okay. This one's a little strange because it only has an I in the denominator. And because it only has an I, the only thing I need to multiply I by to remove it is another I. So I wanted to put this one in here because I knew when you got home and you were looking at this one in your homework, you'd end up having a question on it because, like, where did that just a single I come from? But that's where it ends up coming from. And so I need to multiply it. So I FOIL it and I get 6I. I times positive I is a plus I squared. The bottom, I times I is I squared. So I'm left with 6I. I squared is a negative 1 times a positive is a negative 1. The bottom is a negative 1. But as we've known throughout this whole course, I can never leave a negative 1 in the denominator. So that means all of my signs need to change on the top. And when that happens, there's a 1 on the bottom, but I don't need to have it there. I can get rid of that 1. Okay? So it does not have to be there. And so it's gone. So that becomes my answer for this one. Okay. Questions with that one? So the I that's in there is removed and it's not there to work with. Okay, so again, if you only have a single I just need another I because that makes it remove and become a negative value. If you had an I cubed down here, you would need another I to make it an I to the 4th power. To remove any I's, this value has to be even. So your exponent has to be even on those I's. And we'll talk about that in a second here too. We're going to change some square roots around. Okay, so what about this one? See if you can do it. See what you get for an answer to that one. So hopefully when you get finished working with this one's kind of a sign thing. I had to be careful making sure that you had that -1 in the top. Square root of 2 times square root of 2 is 2. So it's a -2. 2 square root of 2 times a -1 is a negative square root of 2. 1 times a negative square root of 2 is a negative square root of 2. And finally, 1 times a -1 is 1. And so we get 1 in there. And then the bottom, first terms, negative times a negative is positive. Square root of 2 times square root of 2 is 2. 1 times a -1 is a -1. Subtract them, get 1. And in the top, -2 and a -1 is -3. Those two get combined, and you have your final answer. So there's a couple things they throw in, of course, leaving radicals in here, so you're still practicing with your radical stuff along with your eyes and coming up with those. Questions on doing this stuff? You think you're good? Or you need some more? Think you're good? Okay. As long as you do, we're good with that. Powers of I. This means that we can have all kinds of different i's and raise those i's to a variety of different powers and a variety of different levels within that. And so if I have I to the first power, that's simply going to give me plain old straight I. Okay? If I have I squared, we said that was going to be equal to a -1, kind of my 1 looked kind of like an I, get that part out of there, is going to be a -1 because we said anytime I have an I squared, I get a -1 out of it. I cubed, if you break I cubed apart, it's made up of an I times an I squared. And because of the I squared in there, that's what gave me the -1, but I still had an I left over, so my I is negative. So I have a negative I. So odd powers, you're going to have an I left over in most cases when you work with those. If you have I to the fourth power, that is an I squared times an I squared. Since it's an I squared, it equals a -1, and an I squared equals a -1. So a -1 times a -1 is a positive 1, okay? So you end up with those. So if we looked at I to the 5th power, what does it break down to? So I'm looking for how many I squareds I happen to have in these. So if I'm looking for only I squareds, I can kind of do the same kind of thing we did when we had radicals. When I had a radical with a cube root out here, and I had an a to the 5th power, I looked for how many times I could get 3's out of that a. Bless you. And if I get 3's out of that 5, how many 3's come out of 5? I can get 1. So under my radical, I had a cubed times a squared. So that meant I could pull out an a and left me an a squared underneath. And we did those a while back, and 9.2 is where that happened to be. And so because of that situation in there, I could end up coming with what I needed. Well, if I look at I squared, or i's to a power, i's to the 5th power, every time I get an I squared, it's equal to a negative 1. So if I look at 5, divide it by 2, I can get 2 groups of I squareds out of that. And my remainder is a single I. So what does this tell me? I have a negative 1 times a negative 1 times I, or I have just a plain old I left over, because a negative 1 times a negative 1 is 1, and I don't need to write the 1 out in front. So if I always look at those powers in there and I come up with those, I can figure out what in the world I have. In Hawks, they have you work with I to the 4th power. But if you work with I to the 4th power, you're left not knowing whether you got another I squared in there. If you work with I squareds, you'll get a negative 1 and raise it to whatever that power happens to be. So let's take a look at a few of those and see what we can do with them. So if I have I to the 45th power, kind of looks like, boy, what in the world am I going to do with that thing? But if you take 45, because I'm looking for squares, and divide it by 2, 2 goes into 4 twice, 2 goes into 5 twice, with 1 left over. What this means is if I have an I squared 22 times out of that 45. So if I have I squared 22 times, that means I have a negative 1 to the 22nd power. Well, if I have a negative 1 to the 22nd power, anytime this power is even, like it is now, that means I have a positive 1. But I had a remainder in my 45, so I have 1 I. So my answer is just simply plain old I, because everything else disappears out of it. So I can break it down and get rid of whatever I need. So if you have an even, so an even exponent on a I to the 2nd power means you have a positive 1. An odd number, or an odd exponent on a I squared means you have a negative 1. So you'd have a negative 1 with those. So if I end up with even powers, then I'm good to go and everything works out. So what happens with 58? So if I have 58 in here, because I have I to the 58th power, divide it by 2. How many times does 2 go into 58? 2 goes into 5 twice. 2 goes into 18 9 times. So I really have I squared to the 29th power, making it odd. So therefore, my answer to this question is simply a negative 1. So I don't have any remainders because it divided out perfectly. So my answer is simply a negative 1. So that would be the last thing that I'd be left with. is a negative 1 for that one. So keep in mind those powers. So another one in here. What if I had I to the 23rd power? What would I have when I'm done with that one? So I'd take 23, divide it by 2. And the reason it's 2 is because every I squared equals a negative 1. And so that's what helps me out with this. So I bring down my 3. It goes in there once. So I have an I squared to the 11th power times a remainder of 1, which means I have an I left. And so my total answer on this is odd. So it's negative 1 times I, or I'm left with a negative I. So by not using that 4, I kick out exactly what I need in the end. But again, Hawks is going to use 4 as their divider to break these things apart, because you get a positive 1. But it's not the positive 1 we need. It's knowing what happens with the number of I squareds I have, because that's my sign situation there. So you want to make sure that you break those apart and end up with them. Letter C has a negative 7, I to the negative 7th. What in the world does that mean? That's going to mean that I have 1 over I to the 7th. And so if I break this thing apart, what would I end up having? Well, 7 divided by 2 goes in there 3 with a remainder. So really I have 1 over I squared to the 3rd power times an I. So I end up with 1 all over. 3 is odd, so I have a negative 1 times I. And that ends up equaling 1 over a negative I. But we can't leave an I in the denominator, so I'm going, or a negative, so I'm going to multiply top and bottom by a negative I. And so what am I left with? 1 with a negative I all over 1. And so my answer is simply a negative I. I don't think you run across any of these in your homework. I don't think they're in there. They were in the note part, but I don't think they're in your homework. So it flips it to the bottom, but you end up getting your piece in there. So be careful with those. It just means that you got to put it to the denominator, make it positive when you're working with it. So, but then if you got an I left over, you got to move it to the top. So it's a little involved with that one, but it works out that way. Questions with these? Need to do more of those. All you're looking for is how many I squareds, because every I squared you get equals a negative 1. And so therefore, this exponent tells you whether it's positive or not. And again, if it's even, you know you're going to have a positive 1. If the exponent is odd, you're going to have a negative 1. So keep that in mind when you're doing those. So any more of those we need to do? Or you think you're okay with that part? Then the last piece is practice ones. And so it gets in and does some practice problems in here with what we have to do. So in this case, negative 2i times 3 is a negative 6i. Negative 2i times a negative 1 is a plus 2i squared. So this whole thing is really going to equal a negative 6i. I squared is negative minus 2. And I cannot do anything else with it. So keep that in mind when you work with those. This one here, FOIL stuff, and I've got it worked out in another spot here. We kind of don't have enough room. I guess I could pull it down here. 2 plus 4i times 1 plus I. 2 times 1 is 2. 2 times I is plus 2i. 4i times 1 is a plus 4i. 4i times an I is a plus 4i squared. So I get 2 plus 2i plus 4i. Sign changes, and 2 minus 4 is a minus 2. 2i and a 4i is a 6i. So we can work it out that way and come up with what it would be. I to the 13th. 13 divided by 2 and figure out how many I squareds you have. and then you're going to come back and figure out what your values would end up being for that. A negative I, so that just simply moves it to the bottom and makes it a positive I squared, or 1 over a negative 1, or simply a negative 1 when you work that one out. Conjugates on these last two, and again, I've got them worked out, so I'll show you where those happen to be. So if you're watching the video, you can just simply stop it and take a look at what those happen to be. And so there's this one worked out, and this one. The 13i, divided it by 6, came up with I squared to the 6th, and with a remainder of 1. So since it's odd, or since it's even, I should say, I know I have a positive 1, and I just have an I left over. This one, moved it to the denominator. Here, work this one out. I don't know if I can get the whole thing in here. Conjugates, worked all the way through to the bottom, and this should have a 13 on the bottom. For some reason, my copier cut it off with that one. And again, you can stop it to look at what those happen to be. And finally, the last one, number 6. And in number 6, same thing, conjugate. 2 minus I becomes 2 plus I. Multiply top and bottom, combine stuff together, and end up with your final results down here. Just 13 plus 9i to the 5th. Okay, questions with these things. And then finally, there's all the answers to all of those. Now they do break these apart, but I think in Hawks it'll accept them together over one denominator. It should with that. So you're good there. The reason they put zeros in here is because they're saying there is no real value. In here, there is no I value. But again, it will accept just plain I, and it will accept just plain negative 1 for those. So realize that that's the way it does those, but you don't have to put them and write them out like that. Okay. All right. End of chapter 9. So that means review time. So the review is in Hawks as well. So make sure you get your review done. Then your practice test. If you create a practice test, you need to have 35 questions. And again, if you do a practice test, it makes a difference in your regular test. I noticed that off the bat with everybody. And those who do practice tests end up doing better on the regular test. So make sure you end up doing the practice test with these. That's again worth +5. And if you have all of your homework done, you'll end up getting your extra +4 with that part. So, so we're done with what I had to go over today. So get this stopped.